Hi, this is Rocco Boxer, and I was on a dive recently where I had to carry my tank down to where we put in the water, and I was curious about how much does the air that we compress in that tank weigh at the start and end of a dive. And we can figure that out pretty easily with the ideal gas law. And the ideal gas law states that pressure times volume equals the amount of a substance times a universal ideal gas law constant times temperature. And the real challenge here is to get the units right on all these measurements. In our case, P equals pressure, and that is going to be in PSI. And volume equals cubic foot. And for our case, with what we call an 80 cubic foot tank, which is a nominal 80 cubic foot tank, the volume in a scuba tank is actually 0.38 cubic feet. So what that means is if I compress that 3,000 pounds of air into that 0.38 cubic foot space, which is the space inside that cylinder, if I expanded that at 1 atmosphere pressure or normal, sea level pressure, it would, what would it expand out to cover? And it would cover 80 cubic feet equivalent at that same pressure. So what our real volume is 0.38. The tank is referred to as an 80 cubic foot tank. So we're going to use 0.38 in our calculation. N equals the number of moles in the tank, and that's a chemistry equivalent. It's really how to count molecules, and for our case, we're going to call it pound moles. Okay, and we'll worry about how to convert that to mass later on. It's a simple calculation. R in our case is a constant, and that's going to be pounds per square inch times cubic feet divided by pound moles times degrees Rankine, which is our temperature measurement. And temperature is measured in degrees Rankine, and that's really a temperature scale that's based on absolute zero. On the Fahrenheit scale, there's a similar measurement for the Celsius scale, but for the Fahrenheit scale we use Rankine, and that equals the degrees Fahrenheit plus 459.7. Okay, so those are the dimensions that we're going to need for our calculation, and now we just really solve for n. So if we solve this equation here for n, we have n equals PV over RT. Pretty straightforward. So in our case, n is going to equal 3,000 times 0.38 divided by this constant, which I looked it up. For these dimensions, this constant is going to be 10.73. So we'll put 10.73 here, and then we're going to multiply that. We're going to multiply that by our degrees Rankine, which is going to be 72, which is the temperature it was when I dove that day, plus 459.7. Okay, so this thing slides around a little bit. I apologize for that. So if you do those calculations, we get n equals, I think it's 1140 divided by 5,704.14, to be exact today. And that brings us to 0.2 pound moles. Now, what we have to do is we have to convert these pound moles into pounds. That's what we want to measure, right? Well, to do that, we basically multiply by the molecular weight of air. And air is not a single gas, right? Air is made up of multiple gases, nitrogen, oxygen, argon, little trace elements of helium, etc. but the molecular weight of that combined gas mixture we call air is 28.7, or I'm sorry, 28.97 pounds per pound mole. So if we multiply 0.2 by 28.97, we will end up with 5.8 pounds air. That's what it weighs at 3,000 psi. Okay? So that's how much air is in your tank when you start. When we dive down to 500 psi. And 500 psi is our reserve pressure. So what we want to understand is at 3,000, we have 5.8 psi. And we're going to take that down to 500 psi. And how much does that weigh? Right? We don't know. But if we do this math, what we find out is x equals 1 pound. Okay? So a single pound of air is left. So we're going to go from 5.8 pounds when we start down to 1 pound when we finish. Okay? So we're going to consume in our breathing about 4.8 pounds of air. And so that's what our tank weighs at the beginning, what our tank weighs at the end, and how much air we consume on a typical dive, starting with 3,000 cubic feet of air. I'm sorry, 3,000 psi of air at 80 cubic feet. If you have any questions, just put them in the comments, and I'll try to get back to you. Thanks.